Hello everyone. Today we are going to talk about instantaneous center of zero velocity. So every word in this phrase is very important for us. We are looking for a center, for a point about which our rigid body is rotating. And that center has a zero velocity. And also we are interested in instantaneous center, which means that that point keeps changing at different times. A simple example would be a rigid body that is rotating, is pinned at A. So this rigid body's center of zero velocity would be A. So at any point, this rigid body is rotating about point A. Instantaneous center of zero velocity is also referred to as IC, instantaneous center. Now think about a disk that is rolling on the ground with a given angular velocity of omega. What would be IC for this disk, for this rigid body? What would be the center of zero velocity? A center that the velocity would be zero at that point. It would be the point of contact here. So that would be our IC, center of zero velocity. If we have rolling, the velocity here would be zero. And it's instantaneous. So after a moment, then this disk is rotating and IC, this location would be our new IC. And every point on the rigid body is rotating about this point. If you want to find a velocity, let's say at a point O, at the origin, or at the center, the velocity O would be our R omega, and R would be the distance between the center and also IC. If you want to find a velocity here at the top, let's call it VB. It's again about the distance from the center of zero velocity, which here would be 2R omega. So if we find the center of zero velocity, then we can find the velocity at any other point on our object. If a disk is not rolling, if we don't have any friction here, let's say mu is zero, let's say we have lubricated the surface with oil, then the disk is rotating about its axis, about its center. In that case, the center would be our IC, and the disk is rotating about its center with a known omega. So at the top, the velocity would be to the left, and at the bottom, the velocity would be to the right. So the important thing about this center is that it has zero velocity and it's instantaneous. So it's not necessarily the same at all times. At a different time, at a different moment, IC changes. Similar to the example that we talked about here. If a disk is rolling, at any moment, the point of contact with the ground would be our IC, instantaneous center. You need to pay attention that we are talking about velocity here. We don't have such a thing as instantaneous center of zero acceleration. Whatever we talk about here is about velocity, and it should not be used for acceleration. So if you're just going to put into the word what we talked about, after identifying IC, the objective is to find the velocity at any point on the rigid body at that given instant. And IC is not constant, it can be changed at different time. And we need to pay attention to use the concept of IC for velocity, and we can't use it for acceleration. And now, how can we find that instantaneous center of zero velocity? We can find this center if we know the direction of velocity at 2 points on the rigid body. Let's review that. Let's look at some examples here. So for this example, we have a rigid body that has two members, AB and BC. We want to find the location of IC for member BC. So we know the direction of velocity at 2 points at this member. We know it at C, that would be BC, and we know at B. So we are saying that if we know the direction of velocity at 2 points, we can find IC. To do that, we need to draw perpendicular line to the velocity. So if the velocity is in the x direction, I need to draw a perpendicular line. Same thing for the velocity at the other point, which is B. So perpendicular to the velocity at B would be just the direction of rod AB. So I just continue that. The intersection of these two lines would be my IC. So for member BC, IC is located here, which means that member BC at this particular instance, at a given theta and omega, is rotating about this point with this angular velocity. Let's go and look at another problem. Determine the location of IC for member CB when, again, IC is instantaneous. So at a given time, we can find IC. When DC and AB are horizontal. When this rod, DC and AB are horizontal. When they are horizontal, then it's easy to find the velocity. We want to find the velocity of link CB, which means that we need to know the direction of velocity at 2 points. Our 2 points of interest could be C. We know the velocity at C would be in this direction, and the velocity at B would be in this direction. So I know the direction of the velocity at 2 points. Now all I need to do is to draw a perpendicular line to these two velocities. So let's draw these perpendicular lines. Okay, and find out where they intersect. So you can see these two lines are parallel. So where would be IC? In this case, IC would be at infinity. So the location of IC is at infinity. Or you can say that there is no IC, there is no instantaneous center of zero velocity. So what would be the omega of this link CB? We know the velocity is R omega. If we have the velocity and you want to find omega, it would be velocity over R. So if R, the distance to IC, is at infinity, omega would be 0. So there is no rotation for this case. We could see that by observation as well, because there is pure displacement or pure translation. If you remember, for rigid body, we have 3 different types of motion: rotation, translation, and general motion. Here, there is no rotation, so it's just translation. That's why IC is at infinity. Now let's look at another example. We want to find the IC for the ladder. To find the IC, we need to know the direction of velocity has 2 points. So 2 points could be, 1 point could be here, the other point could be here. Because of the gravity, this one is gonna try to fall down in this direction. This one will go in that direction. So these are the directions of the velocity. To find IC, I need to find the intersection of the perpendicular lines to this. So that would be my IC. So we found instantaneous center of zero velocity for 3 examples. So we know how to find it. if we have the direction of velocity at 2 points. And the objective is to find the velocity at any other points. Now that I have IC, if I had the magnitude of these velocities, I could find omega. And once I have the center of rotation, IC, the important about IC is that it is the center of rotation. And if I have omega, then I can find a velocity at any point. And I can find a velocity direction at any point of interest.